Hello everyone, I am Mr. Palace and this is Lab 21A. These are electrical circuits, and if you haven't already been aware, there are two types. There are series circuits and parallel circuits. So first we're going to start with a series circuit. If you notice in the diagram, there is one path for the electricity to flow, and so we're going to start out with two batteries. Make sure that the ends of the batteries are pointing in the same direction. We have a switch and three bulbs. So first we're going to measure voltage. So make sure your meter is connected properly. The black wire is always in the bottom, the red wire is in the middle position, and your dial is set to 20. So we're going to measure from A to B, and that is the first light bulb. So I'm going to close the circuit. The bulbs are lit, and I'm getting a reading of 0.99. Alright, so that goes between A and B. We're going to measure between the second light bulb. Alright, and again, if you get a negative number, you can switch the wires or just ignore the negative sign. But for the second light bulb, I'm getting 0.92. So write that down. All right. Third light bulb, same measurements. I'm getting 0.97. And lastly, I'm going to connect before the first light bulb and after the last light bulb. And I'm getting a total voltage drop of 2.90. And remember, if you have the negative sign, just ignore it. All right, there's a couple questions to answer, and then we'll begin the next part. So answer those questions, pause the video. When you're ready, move on to part 3. All right, on to part 3. These are the current of the series circuits. And so Mr. Schindel is going to measure across the open switch, and we are measuring amperage. So with 3 light bulbs, we are measuring an amperage of 0.08. All right, Mr. Schindel is removing one light bulb. And so now we have 2 bulbs. He's going to measure across the open switch again. And now we have 0.09 amps. All right, removing removing one more light bulb, so we have just one left. Measuring the amperage across the open switch, we get 0.12 amps. All right, so the amperage is changing as we're varying the amount of light bulbs. Answer the following questions, and then we'll begin step 5. And now we're on to part 5. Then we're going to create a short circuit. And so if you recall, short circuits are a shorter path for the electricity to flow, and electricity will take the path of least resistance. So we have 3 light bulbs set up. We added a second battery to make the bulbs brighter and more visible. Your teacher may or may not ask you to do this in class. So we're going to measure the amperage across the open switch again. Mr. Schindel is going to measure. We're going to record that on the next page. So we have an amperage of 0.08. All right, I'm going to attach the short circuit between or after the first bulb and after the third bulb. Measure that amperage again. Notice only one bulb is on, and we have an amperage of 0.13. All right, there's some questions to answer here, and then it's on to parallel circuits, part 7. All right, ladies and gentlemen, it's part 7. Now we've constructed a parallel circuit. You'll notice that's a lot more wires involved. This is how your homes and residences are wired, because it's a lot easier to deal with when you have a bad wire or short circuit. So we are going to measure the voltage across the entire circuit. We'll measure the total and each bulb separately, and then we will measure the current going through the circuit. So here we go. I'm going to put my leads on each end of the 2 batteries. This will give us our total voltage coming out. And remember, ignore that negative sign. We have 2.71, let's say. And now I'm going to measure each bulb separately. All right, bulb 1. 2.65. All right, second bulb. 2.65 again. And third bulb. Well, it's bouncing around again, but let's be consistent. 2.65. All right, now this is where Mr. Schindel is going to measure the amperage, but you remember you're going to have to switch around your meter. The red wire is at top, and you're switching to the amperage position. And the amperage going through the system, bouncing around a little bit, let's call it 0.36. All right, there's the data. You've got a few questions to answer, but that's it for Lab 21A.